In this question, we have a cumulative frequency graph which shows the information about the length in minutes of each of 80 films. Now, the first question here, we are requested to use the graph to find an estimate for the interquartile range. So the first step here is to look at the maximum number of films that are given here. So from the cumulative frequency graph, the maximum number of films is 80, as it's stated in the question. So halfway will be the median position. So this is the position of the median. And then between the maximum and the position of the median, we have the position of the upper quartile. So position of the upper quartile. And then between 0 and 40, we have the position of lower quartile. So this is the position of the lower quartile. Now, what we want is the interquartile range. Now, interquartile range is upper quartile minus lower quartile. So we need to find the upper quartile and the lower quartile. These are just the positions. So to find the upper quartile and lower quartile, you have to grab your ruler, and then using your ruler, you draw a horizontal line to estimate the lower quartile. So if you draw this carefully, might end up somewhere there, which is approximately about 103. I'll write that in a minute. And then for the upper quartile, you do the same thing. You draw a horizontal line all the way to the end. And you have to be careful because you want, accurate results. All right. And then a vertical line from here, somewhere there, vertical line, which will be somewhere here. Okay. So from here, we can see that this value here is 103, and this is 123. So basically, our interquartile range will be 123 minus 103, which will be equal to 20. Okay, so the next question, Claire says that more than 35% of these films are over 120 minutes long. So the question is Claire correct? So we have to check that. So 120 minutes is about here. That's 120 minutes. So we need to check how many, we need to find out the number of films that are over 120 minutes. So again, this is the point again where you take your ruler and draw a vertical line from 120 all the way up to the line, and then a horizontal line all the way across from that point all the way across, so somewhere around there. Now again, if you look carefully, this is about 55. It's about 55. So we can see that the number of films over 120 millimeters long are 55. So let's write that down here. So we can see that the number of films, so number of films over 120 millimeters long will be equal to, and the way I got actually the number of films that are over 120 minutes long will be 80 minus 55. So that will be, because that's over. This is the range that you're looking at here. So that will be equal to 80 minus 55, which will be equal to 25. All right, so, and then here we're talking about percentage. So basically the percentage of films over 120 millimeters long will be 25 over the total number of films, which is 120 multiplied by 100. So let's write that down. So the percentage of films over 120 millimeters long will be equal to 25, which are the number of films above 120 minutes, over total number of films, which is 80, multiplied by 100, and that will be equal to 31.25%. But here, what Clay is saying is that more than 35% of the films are over 100, and this is incorrect because you can clearly see that the number of films that are more than 120 centimeters long, the percentage of films will be 31.25. So we can say that Claire is incorrect. So Claire is not correct, okay, because of the reasons that are provided there. Okay, number 3, the cumulative frequency graph gives information about the monthly rainfall in millimeters in UK during 120 months in the years 2001 to 2010. So here we expected to estimate the number of months for which the rainfall was less than 50. Again, 50 is about in between here. Actually, not there. 50 is somewhere around here. Somewhere there. So we have 50 here. So we want to estimate the number of months. The number of months here is represented by the y-axis, less than 50. So you have to take your ruler, draw a vertical line somewhere there, and then a horizontal line from there all the way to somewhere there. And if you draw it properly, I mean, that's from the scale that's given, that value is about 10. Yeah, so that will be 10 months. Okay, so the next question is use the graph to estimate the median. Again, just like I explained in the previous question, this is the maximum here. And then, so the position of the median will be halfway. So half of 120 is 60. So this is the position of the median, position of the median. And what you do at this stage is you take a ruler, draw a horizontal line from here, 60, all the way across to the curve, and then a vertical line from there all the way down. Yeah. So, I mean, if you look at this scale here, uh, this value here is about 90. So, we can go ahead and just say here 90 millimeters. Okay, and then the next question is use the graph to estimate the interquartile range. So the interquartile range, again, I'll just write here the same statement I wrote above there. Interquartile range is equal to the upper quartile uh, minus the lower quartile. Again, what you need to come over here and do is first of all find the positions of the upper quartile and lower quartile. So halfway between 120 and 60 is 90. So 90 is somewhere here, and this is the position of the lower quartile. And then halfway between 60 and 0 will be 30, which is here, and this will be the position of lower quartile. All right, so, and then you grab your ruler and apply the same process. So horizontal line all the way to the line, and then you drop it. So, well, here we can see that, so that's 120. So 20 and then 40, 60 is here. So, well, I'm getting something close to 64. Um, but again, if you look closely, I haven't drawn this line properly, so I'll just draw it properly here. Um, so it has to touch the curve, so draw from the curve so that you get accurate results. Otherwise, if your line is not accurate, you won't end up with the right results. Anyway, so here what I have is about 66 because each square represents 4 units on the horizontal axis, and then horizontally from 90 again, draw a line all the way to the curve, and then drop that line all the way down, and if you notice, that's 90, so 1, 2, 3, 4, 5. So basically this is like 120 um, minus 4. Let's just say this is about 116. All right, so those two values are the upper quartile and lower quartile. So the upper quartile is 116, the lower quartile is 66, and that difference is about 50. So approximately 50, that's the interquartile range.